We have been doing a lot of work with the equation of a linear relationship, y equals mx plus b, and then graphing the line that represents the relation. We know that in this equation, the m stands for the slope of the line, and that the b in the equation stands for the y-intercept of the line, so where the line crosses the y-axis. If you have any questions about graphing a linear relation, please make sure you ask in our OneNote collaboration space or message me. We are going to continue working with linear relations and the equation y equals mx plus b, but we're going to do something a little different than we did in our last lesson. So in our last lesson, what we did was you were given the equation of the relationship. Okay, you were given y equals mx plus b for that relation, and you were asked to then create the graph. So that involved identifying the slope as the m in front of the x and identifying the y-intercept and using that information, the y-intercept and the slope, to graph the line. What we want to do today in this lesson is I'm going to give you a graph of a line. Graph of a linear relationship. And what you're going to be asked to do is, what is the equation for that relation? So here's a question which asks you to determine the equation of the linear relation shown. So here's a line given to you, okay? What is the equation of that line in y equals mx plus b form? In order to do this, we need to identify what is the slope of this line and what is the y-intercept of the line. Okay, let's look at the graph. And I think let's start with the y-intercept, because here's our line, and where it crosses the y-axis is right here. So if you would agree with me, I think the y-intercept of this line is 3. That means the value of b in the equation is 3. Okay? Simple enough. Let's now look at the slope of the line. So remember that slope is a measure of how steep a line is, and it's calculated by the formula rise divided by run. So let's look at this line right now. I can see that there are 2 points that are given on the line, one here on the left and one here on the right. Okay? The rise of the line refers to the vertical distance that we would need to travel to get from one point to the next point, and the run of the line is the horizontal distance that you would need to travel. Okay, so I've just drawn in my rise and run. This one is my rise, and this one is my run. Okay, and let's determine that rise and that run. So I would have to go 1, 2, 3, 4, 5, 6 units down. Okay, now because we're moving downward, that means our rise is negative. So I'm going to say that the rise of this line is -6. Okay, and I'm going to put that in the formula over there. Okay, now let's determine the run. I would need to now move 1, 2, 3, 4, 5, 6, 7, 8, 9 units to the right. Okay, so the run of this line is 9. So I put that in for run, and I have a slope of -6 over 9. Okay, now if I took out a calculator and I divided -6 by 9, that would give me a decimal. And I don't want to give my slope as a decimal. I want to leave it as a fraction. But when I look at this fraction, -6 over 9, I realize that it isn't in simplest form. So I'm going to put that into simplest form right now by dividing both the top and the bottom by the greatest common factor, which would be 3. So negative 6 divided by 3 is negative 2, and 9 divided by 3 is 3. That means that the slope of this line is negative 2 over 3, or negative 2/3. Okay? We can now put both of these pieces of information together. What pieces of information am I referring to? We started off by determining the y-intercept of the line to be 3. And then we now determine that the slope of the line is negative 2 over 3. Okay? That means that the equation of this line is y equals m, which is negative 2 over 3, x plus b, which is 3. Our equation is y equals negative 2/3 x plus 3. The remainder of the examples in this lesson will ask you to do the same thing. That is, determine the equation of the line whose graph is given. But they will show you different types of lines. So let's try example number 2. We want to determine the equation of the line in y equals mx plus b form. So we're going to start off by identifying the y-intercept. This line crosses the y-axis at the point that I'm drawing right now, which is at negative 3. So that means my b value is negative 3. Okay? And now I need to determine the slope of the line by calculating the rise and the run. So this example, when I look at the line, it isn't giving me any points on the line. When I look all along the line, there are no dots there, right? I have the point that I just drew. In order to calculate rise and run, I need 2 points on the line. So let's trace along the line and find some points that are easy to determine where they are, okay? And what I mean by that is, I would say if I move along this line, this point right here, it's easy to determine because it has integer coordinates. As opposed to, I wouldn't want to draw that point because that's in the middle of a grid mark, okay? Here's another one that I don't think is very easy to determine where that point is, or this one. All of the green points, those are hard to determine where the exact coordinates of those points are. I've got this red one that I put there. I could put another red one right here if I wanted to. Those to me are easy points to determine, okay? So you want to find 2 points that are on the line, and you want to draw the rise and the run to get between those 2 points. Okay, so if I chose those 2 points right there, the rise would be 1, 2, 3, 4. Okay, and the run would be 1, 2. Okay, using my slope formula, that would give me a slope of 4 over 2. And when I look at this fraction and I divide 4 by 2, I don't get a decimal. I get 2. I do want to divide those two numbers because it doesn't give me a decimal. So the slope of this line is 2. Okay. Now, if we were in the classroom, I think that there might be some people that would ask me the following question. Would I get the same answer if I chose 2 different points? Okay. And my answer to that is yes, you would get the same answer for slope. Okay. So what I want you to do is I want you to pause the video right now, and I want you to determine the slope of the line that goes from this yellow dot here to this yellow dot here. They're both points that are on the line, okay? Go ahead right now and find the slope. So if you find the slope between the two yellow points that are on the line, I got a rise of 8 and a run of 4. And when I do 8 divided by 4, I still get an answer of 2. So I just wanted to show you that it doesn't matter what 2 points that you choose to calculate your slope. The slope is the same all the way along the line, so it will give you the same answer. Okay? Let's write down the final answer to this question. Okay, the equation of this line is going to be y equals, we had a slope of 2, so that goes in place of m, and we had a y-intercept of -3, so that goes into the place of b, and we get this equation, y equals 2x minus 3. In example number 3, the line that is given is a horizontal line. Let's see what happens when we determine its equation. So y equals mx plus b, starting by identifying the y-intercept, occurs right here on the line. So the value of b is -1. Then let's calculate the slope. And slope is rise over run. Or some of you might be thinking, don't we already know that the slope of a horizontal line is equal to 0? Slope measures steepness of a line, so a horizontal line is totally flat, and it does have a slope of 0. Let's calculate it just to reinforce that idea, okay? So if I move from the point on the left to the point on the right, and I try and calculate rise and run, there is no rise. You are not going up at all to get from this point to this point, okay? So the rise of the line is 0. The run of this line to get from the point on the left to the point on the right would be 1, 2, 3, 4, 5, 6, 7. So the run is equal to 7. So looking at my formula, rise over run, I would have 0 divided by 7. And the answer to 0 divided by 7 is 0. Just like we said in the first place. So I don't mind if you do not do this work and you just notice that whenever you have a horizontal line, its slope will always be 0. Okay, so now let's go back to the equation. The equation of the line is y equals mx, so our slope is 0, 0x, plus b, our b is -1. Okay, our y-intercept is -1. Okay, this can be simplified in this case. Looking right here at 0x, okay, the operation between the 0 and the x is multiply. So what happens when you take 0 and multiply it by x? Well, 0 times any number gives you an answer of 0. So this 0 times x is just 0. And adding -1 is the same as just subtracting 1. So I get y equals 0 minus 1. The answer to 0 minus 1 is just -1. So for a horizontal line, when we do y equals mx plus b, and we simplify it as much as we can, we just get y equals -1. It's a very special case of y equals mx plus b. Any line that's horizontal is not going to have an mx in its equation. It's just going to have the y is equal to the b. And I want you to realize that this actually makes sense if I think about it, okay? I want you to look at the points that are on this line, okay? Here's a point, here's a point, Here's a point. I could draw more points in there. There are points all the way along this line, okay? And I want you to look at the coordinates of those points. So let's start with the point here on the left. This point has coordinates -4, -1. The next point right here, I hope you would agree, have coordinates -1, or sorry, -3, -1. If I move to this next point, as I move to the right here, this one has coordinates -2, -1. And I hope that you see a pattern if I continue to do that. This one is -1, -1. This y-intercept is 0, -1. What do all of those points have in common? Well, if I look at them, all of those points have a y-coordinate of -1. So to me, it kind of makes sense that the equation of this line is y equals to -1, because every point on the line is going to have a y-coordinate of -1. Okay? That's a special case for horizontal lines. Vertical lines also represent a special case of y equals mx plus b. Okay, if you look at this line right now and you try to determine its y-intercept, it does not cross the y-axis, so it doesn't have a y-intercept. So what are we going to put in there if it doesn't have a y-intercept? I want you to think about that. We can't put 0 because it doesn't go through 0. Okay, this line doesn't have a y-intercept. Now let's consider the slope, okay? The slope of this line, if we use rise over run, okay, gives us a special case also. When I move from one point to the next, I would rise 1, 2, 3, 4, 5, 6, 7 units, but I wouldn't run at all. So the run is 0. And if you recall, any number divided by 0, your calculator gives you an error, and it's called in mathematics undefined. Okay? A vertical line has a slope that's undefined. So how do I put undefined into this equation right here where the m is? It doesn't work. So far, I have no idea what I should do for this vertical line. Doesn't have a y-intercept, and the slope is undefined, okay? So I want you to consider the following. I'm going to do the same thing that I did with the horizontal line in the previous example. I'm going to draw some more points that I know are on this line. There's a point, there's a point, okay? All of these are points that are on the line. And I want you to consider what are the coordinates of each of those points. Okay, so let's go up to the top here. This point has coordinates 2, 4. If I move down to the next point, it has coordinates 2, 3. And if I keep moving down, the next one would be 2, 2. The next one would be 2, 1, 2, 0. Look at each one of those points and ask yourself, what do they have in common? Okay, what do those points have in common? Well, if I look at each of those points, they all have an x-coordinate of 2. Every single point on that line has an x-coordinate of 2, okay? And that's why when we do vertical lines, the equation of a vertical line is going to be of the form x equals, in this case, -2. And that -2, I'm going to introduce something new here. -2 is the x-intercept of the line. We've always talked about y-intercepts, which is where a line crosses the y-axis. We can also talk about x-intercepts as being where a line crosses the x-axis, okay? And the equation of a vertical line will always be of this form. X equals the x-intercept of the line. So I just wanted to show you a summary of those two special cases, horizontal lines and vertical lines. If a line is horizontal, we know that its slope is equal to 0, okay? And so when we try to do y equals mx plus b, it will simplify down to just y equals b, where b is the y-intercept of the line. The other special case, vertical lines. Well, vertical lines have a slope which is undefined, okay? So that when we try to do y equals mx plus b, it doesn't work at all. And therefore, the special case for vertical lines is that its equation will be of the form x equals a, and a is the value of the x-intercept of the line, okay? So now, after watching this video, I want you to practice coming up with the equation of a line if I give you the graph or if I give you the slope and the y-intercept. So your next task is going to be to complete some practice questions from the textbook.